Hello Godottians, it's Andy, the GDScript dude, with another video in the Tetron game development series. In this video I will be making a shapes factory which will produce shape data objects. But before doing that, I want to make some changes to the shape data class. I decided not to have a cells property. This is where we copied the visual cells, because when I rotated them, the cell tiles don't look right. Okay, let's save that and commit the changes. So we'll go in here in tortoise git. We're going to commit the changes with a message and commit the changes. Commit. Just close. Okay, now let's look at the shapes scene. What we're going to do is make this into a autoload. What we will do is add a script to the shape scene. Add a script. We'll register it in project settings under autoloads. Shapes scene. Open. And then add this. It will be called shapes. Now this shapes autoload will be available globally throughout the game. You see that in the background you can see the auto-loaded shapes scene. So what we should do is hide the shapes. So we just click on this icon here and then they'll be gone. So the next thing to do is start coding the shapes factory. Let's start with some properties. Var be a local property, call it a shapes array. This will hold all the shape data for each of the various shapes. Briefly going back to the shape data class, I noticed we had this warning sign here. So if we open that up, we see that it's saying the class variable color is being declared but never used. That shouldn't really be a warning, because it will be used because it's a class when we instantiate an object of this class later. But what we can do is we click ignore. So you can see after clicking on ignore, I get this inserted. After clicking on ignore, the editor inserts this line here, which is a preprocessor instruction. Okay, now we can save that and we should commit the change again. Let's go there, commit to master, the commit message, commit. Okay, let's go on and start coding our shapes factory. We would like to have a function called getShape. Let's specify what type of return value this function produces. It'll be a shape data object. Let's start by adding a new variable. Let's say s equals shapedata.new. And then let's return s just to start filling out the code. Let's add a property to store an array of all the various shapes. So we'll have a variable called underscore shapes and equals an empty array. And to populate this array, let's use the ready function. We will scan through the shapes which are in the scene. So let's have a for loop and loop through the children. So here we have for shape in get children. We will have a new shape data object for each one. We will copy property values into this data object. For example, the name and the color properties taken from the shape. For example, the name and the color properties. So we directly copy the name and we get the color from the modulate value of the shape. Now let's consider the shape itself, and we will want to know the size, which we can get from the column count of the grid of the shape. And let's divide that by 2. And if we look back at the shape data object, we want to fill in values for color, which we've done, grid and cohorts. for example, a grid of 3 by 3 dimensions, we'll get S2 equals 1 because size divided by 2 as an integer is 1. So using the range function, we can get an array of numbers ranging from minus S2 through 0 to plus S2. So if the size of the column width was 3, like the T shape for example, we would divide 3 by 2 to give 1.5, except this is an integer calculation, so we'll get S2 equals 1. So the range will be from -1 up to +1. Now we want to remove the 0 coordinate for even size grids. So we will go if size modulo 2 equals 0, we should remove the middle coordinate, which happens to have an index value of S2. Now for testing purposes, it'd be good to print out these values of cores just to check it's working okay. So at this stage we can run this script and then look down at the output, and it looks like it's working okay. See, we get -101 for the first 2 shapes, and then -2, -1, and missing out the 0, 1 and 2 for this 4x4 shape. And then the square shape is just -1 and 1, and the others 1, -1, 0, 1, and it looks like they're all correct. So looking back at shape data, we just need the grid property next. Right, for the grid property, we need to actually work out what the virtual grid is. So let's have a function called _getGrid with input parameters of n for the size of the grid and the cells which comprise the shape within the grid. Our grid will have columns and rows, so let's set up some local variables for grid and row, and we need an index to point at the position within the row. Let's scan across the cells with a for loop for cell in cells. Now let's append a row, and it will be a true or false value depending on whether the cell modulate alpha value is greater than 0.1. So if the cell is blank, the modulate value alpha will be 0. So that should produce a false value for the cell and a true value for when it's visible. Now increment the index position, and if we have got to the end of the column, we want to go to a new row. Let's append the row we just created to the grid. The index value to 0 and reset the row value. Finally, after scanning through all of the cells, return the grid. So now we can call the getGrid function. Let's put that in and apply its return value to data.grid. We will pass in the size value and the children of the current shape. And at this stage we have set all of the shape data object properties. So let's append the new shape data object to our shapes array. So that's the initialization of the factory. Now we want to complete the getShape function. Each time getShape is called, we want to return a random selection from the shapes array. One way to do it would be to use a random index value to pick a value out, but the way it's done is Tetris is we shuffle them like a deck of cards and take each one by one until they've all been selected and then reshuffle. So the array comes with a shuffle method. We will have an index value into the shape starting at 0, and we'll increment it on each call to get shape. If the index value equals 0, we will go shapes.shuffle. This returns a void, so it just shuffles it in place. rather than producing a copy of the array. And let's set the index value at this point to the shapes.size. So we will like count down from the top index down to 0. So on each call to get shape, we will decrement the index value. So now, given we've got a shuffled array of shapes and an index value pointing into them, we will make a copy of the properties of that selected shape and put them into this variable s of the new shape data object. So here's the code for that. So we copy the properties of the indexed shape, the properties of name, color, coordinates, and the grid. And finally we return the shape data object. Right, let's save. Let's run the scene just to check for any errors. No, it all looks okay. So that is the shapes factory complete for now, apart from the need to test it. So in the next video I will create a test scene to check that this works properly and produces shapes and we can rotate the shapes. So goodbye for now and see you in the next video. Like and subscribe.